Hello everyone, welcome and thanks for joining my presentation today. My name is Emel Dogrusoz and I'm the Principal Technical Product Manager at Sawyer Software. It's my pleasure to speak with you today and show you our product Sawyer perspectives and how it can help you visualize your data and get meaningful information from your data. But first, a little about our company. Sawyer Software is a well-established company with a mature, full-featured product, and the company has been in business for nearly a quarter century now. Our product is a software development toolkit with a graphical development environment for building data visualization and analysis applications. And using the graphical development environment, our customers save huge amounts of time and resources while building their applications instead of coding everything. And we are well known as the best graph layout providers in the world today. And our support and development teams provide excellent service to our customers, and we are very proud of that. And in this view, we have a video inset showing the kinds of the visualizations you can build with Sawyer perspectives. Okay, so data relationships are everywhere, among employees in an organization, elements in a network, genes in a biological pathway, and vendors in a supply chain. And the sheer amount of data that's being created every day is mind-dumping. As you can see from this slide, the data that's stored by the industry is doubled every 1.2 years. That means we have really huge data, and we need smart tools to deal with the complexity of this data. Companies with needs in link analysis, in process and project management, in dependency and modeling, and network management all rely on our expertise in graph visualization, layout, and analysis. And basically, since we have big data, the value you would realize by visualizing your big data is increasing. So the companies have complex big data, and the data has relationships in it. And the data may have location information, and the data also evolves in time. So we have a complex situation here, and compounding this complexity is that organizations store their data in multiple data silos. So the question is, how can an organization consolidate that data and make sense of that data for solving their pressing problems? Sawyer perspectives provide different views of your data, different connected views of your data, so that you can see and visualize those different dimensions of the data and find answers to your questions. So how does it work? We can connect to different data sources, a wide variety of data sources like Neo4j or some other data sources like SQL databases and so on. And we read your data and build an in-memory representation of your data, what we call the data model. And then we give you the tools to visualize your data model. So you do all of that using the graphical development environment. So you can integrate with the data sources using the graphical development environment. And you can configure your visualizations again using the graphical development environment. And depending on what kind of data you have exactly, you can build many different view types. Like if you have relationship information in your data, then you would build drawings or graphs to visualize that. Or if you have location information in your data, then you may want to visualize your data on a geographical map. So we provide you all the tools to visualize your data. We have a wide variety of data sources that we integrate with. We have a data integration tooling, and we have support for generic data sources like XML, REST, JSON data, or we also support SQL databases, and we also have product-specific data integrators like for Neo4j. And using those data sources, you can both read from those data sources and also write back to those data sources. So you can have editing capability in your visualization application, so you can play with your data, change your data, and save these changes back to your data source, again using our data integrator tooling. I said that we provide different views of your data. So we have these types of views available in Tom Sawyer perspectives. You can build drawings to visualize the relationship information. You can build timelines to see the time aspect of your data. You can have charts to provide some statistical or summary information of your data. You can visualize location information on maps, and you can complement those other view types with tables, trees, and inspectors. I said that we are the experts in graph layout, and we provide different graph layout styles in our tool. And each of those layout styles are highly customizable, meaning that you're not just limited to a layout output, but depending on your exact requirements, you can change the layout results. And each of those layout styles are, they both support global layout and incremental layout, and they are all scalable, meaning that they can support thousands of objects and still run very quickly and still produce excellent looking drawings. We also have graph analysis solutions. In Tom Sawyer perspectives, we have over 30 different graph analysis algorithm implementations. So with the graph analysis solutions, you can do things like social network analysis, find dependencies, run root cause analysis, or find clusters or group structures in your data. So now I will show you some example applications we built with our product. And I'd like to show you examples from different domains, hoping that you will find at least some of them interesting and familiar with you. So the first example I'll start with is from systems engineering domain, is a systems modeling example. And here we have a drawing view. At the bottom, we have some table views and so on. So this is an internal block diagram. For those of you who may be familiar with SysML or UML, you may already know about internal block diagrams. Here we show the properties with nodes, and we show the connectors with links between them. But different than the traditional UML tools, what you can do with Tom Sawyer perspectives is you can interact with your drawings. Like, for example, I can expand this system object like this and see what it is composed of. Okay. And I can update my layout like this so that it looks nicer. So you can show any level of detail you want in your drawings with Tom Sawyer perspectives, and you can change the level of detail at runtime. In a typical UML diagram, you wouldn't have that kind of interaction. So I'm now expanding what's inside my power subsystem, as I'd like to see more details about my power subsystem. And I'm also seeing details about the selected object in this inspector view, the selected properties, details in here. Also, we have a tree view in here at the left-hand side showing some filter controls and stereotype coloring and so on. And in this second view, I have an internal block diagram, but with a different look and feel. So this is the expanded view of the first internal block diagram. And this is our graphical development environment, as I said. And with this environment, you can connect to your data sources, like with Neo4j data sources or other data sources. And you basically configure your visual components like drawings, tables, trees, charts, all from this design environment. And when you do the configuration in the graphical designer, you get both desktop and web versions of the same application. And we support both Java and .NET lines. Yeah, let's move to another example while this is loading. I don't know what's wrong with that. But now I'll show you an example that shows how commodities flow between different states in the United States. And all of those examples are available in our website, so you can play with them yourself, like go to our website and run those examples. We will be also releasing a new version tomorrow, so there will be some new features and many new improvements introduced in this new version. So I'll select some commodities to visualize. I'm trying to select some commodities that belong to the, that are related to the automobile industry. And I'll select some states and sub-states like Michigan, Texas, let's add Kentucky. So this example shows us how certain commodities flow between different locations. And originally, we had the data in Excel files, but communication with Excel, querying the Excel files is quite time-consuming. So we imported the data to a Neo4j database, and now we are using Neo4j for visualizing it. Whenever I selected those states and commodities, it ran a Neo4j a Cipher query in the backend, and now I see the results. So in this chart, we see that most of the imports and exports are happening in Detroit, Michigan. Next comes some cities in Texas, and the y-axis is showing the amount of value that's being transferred, basically. And this is the logical presentation that Sawyer Perspectives comes up with. Here we have a left to right orientation of the flow. So we have the locations shown with nodes, and we have the commodity flows shown with edges. And edges have different thickness. The thickness information is derived from the amount of the shipment. Like if it's a big shipment, then the thickness, we show it with thicker edges like this. And in Sawyer Perspectives applications, you can expose some settings to in your resulting application. For example, I can say that I want to see the same drawing with a top to bottom flow like this. So I expose some layout settings in my application, just getting it back. Or I don't want to see the edges routed with polyline style. I want to see them routed in orthogonal style like this. Let me zoom in. As you can see, there are no object overlaps, all nicely laid out. Or for example, we can change the edge style from straight to curve like this. So you can expose such settings in your application and give your end users the ability to play with them and find the best configuration that they like. And I can also run some filters. For example, say that I don't want to see these small commodity flows and I just want to see the big flows. So I can set a minimum value and it just updates my drawing like this. Since we have the location information, we can visualize the same information on a map as well. Here we have a Google map and we see the markers for different locations and again commodities flowing. And you are not just limited to Google Maps, but you can also use other map providers like, for example, if you need offline mapping capability, you can use OpenStreetMaps with Sawyer Perspectives. And here we have a table representation for the commodity flow details. Now let me move to another example. And this example is using some public safety information. We have the incident reports criminal incident reports that we got from Seattle Police Department incident reports. So the incident information is real, but the people information in this example is imaginary. In this first view, so we see incidents like this. So this is, okay, here in the filters part, we see incidents categorized by their types. So a police officer may want to just focus on certain offense types using those filter settings. And now I selected a criminal person, and I can see the details of the person here in the inspector view. A person has a link with an incident, meaning that that person was involved in that criminal incident. And for example, this incident is represented with a different icon, meaning that it was of a different type. So this is a vehicle theft. I can open my overview dialog and use it as a navigation control, navigation and panning control, like this. Here at the bottom, we have a timeline view. So we have the records for 2 years, but I can change the time interval and just focus on certain time interval, like from April to, say, September, which filtered my drawing, right? So I have now less data. I'm just seeing the incidents that happened between April and September. And you can also run timeline animation, which would show you how the network evolved over time, from beginning to the end as well. And on a view like this, I can run some graph analysis, like show people's incident involvement and find out who are the highly criminal people, who were involved in many criminal incidents. As you can see, the node UIs got updated, and some people have bigger nodes, bigger UIs now, showing that they were involved in many incidents. And we have a tree view showing the incident involvement degrees. Like this guy was involved in 19 different criminal incidents. And I can see more detail about the guy in the inspector view and also see his picture like this as a tooltip. And at the bottom, we have some charts showing details like, the people's, the criminals, age distribution, like the area distribution of the incidents, and so on. Now let's move to the second view. Here we have the people network, just the criminals networks, who works with whom. So there is a link between two people if they were involved in the same criminal incident. I can change my layout style to circular to reveal the grouping structure. Now, people who work together have a circular group structure already showing that information, the network information. And I can run some additional social network analysis capabilities, like find the cliques in this network. And let's update our layout so that we can see those guys nicely. This assigns some cornice value to each person, and people with high cornice value are in big cliques, and they are important people in this network, basically. But we can run some other social network analysis capabilities as well, like run this betweenness centrality, which would find the middleman in our network. So as you can see, the UIs got updated because now we are seeing the results of the betweenness analysis. And here at the bottom in a chart, we see the betweenness analysis results. Like this guy has the highest score. Next comes, I think, this guy. So we can visualize them nicely like this. And we can also see the same data on a map since we have location information. So this is the map of Seattle. And as you can see, we have some markers, flag markers, and some markers of balls. And the flags mean that there's just one individual incident that happened there, but ball means, there's a group of incidents happening there. And those groupings or clustering of the markers change with zoom level changes. So using such application, for example, police officers may find, who are very active, who are highly criminal people, and they can find the likelihood of incidents, criminal incidents that may happen on certain locations and at certain times. Now I'll show you another example. So in this example, we have an IT infrastructure, and we are visualizing the network devices and the connections between them. As you can see, with zoom level changes, the level of detail displayed in my drawing gets updated, like at higher zoom levels. I can show more details, like show an icon for the type of the device, like it's a workstation, and show the status of the device, like this is okay, and this has an information status. And at lower zoom levels, we don't need to display that much detail because it won't be visible anyways. So you can build such UIs, complex UIs with Sawyer perspectives easily. We have a graphical UI editor for building such UIs. And as you can see, we have the edges to demonstrate the connection information. And each edge has a label for showing the connection bandwidth. And edge color changes based on how loaded that edge is. And so it's, the color goes from green to red, basically. We have a legend here to show that information. And on such example, what I can do is I can run different layouts, like orthogonal layout or circular layout to see the group structure. And I can group my devices based on their location information like this. And at any time, I can collapse my location nodes like this. Now we just see the locations, not what's inside them. But the color of the location nodes, the color is derived by what's inside those locations. This guy is red, meaning that at least one device inside this location has a red status, so has a critical status. And likewise, this guy is green, meaning that all of the devices inside this location has healthy status. So network designers or network planners can just look at the colors of the buildings, of the locations, and decide which areas need attention, like just choose the red areas and only focus on them instead of seeing all of the details. Now let me get rid of the grouping. And what you can do with this example is, we also have some classification, like based on the locations, based on the type. These are my FTP servers, these are my laptop devices, and so on. So you can select them from the tree, and they would get selected in the other views as well. We can also have editing capability in our examples, in our applications. Like a network designer may want to design their network using this application, and they can create new devices and connections between them like this, and change the default values, like for this guy, change this status to say warning, or change the IP address like this. And then we can save those changes back to our data source, whether it's an Excel file, whether it's a SQL database. We can save those changes back to the data source, and next time when we load the application, we would see that the changes would come, and we would see the changes. Back to my first drawing. So I showed the internal block diagram. And I expanded my system object. This. And let's expand the power subsystem as well. As you can see, we have the crossing jump overs on lines showing the crossings, but you can display the crossings with different UIs as well, not those jumps, but you can have like circles, or you can customize the appearance as you like. We have connectors or ports, what's called ports in some applications, in Sawyer perspectives applications. And in here, we have a block definition diagram as well. I guess I broke something with this example while playing with it, but okay. So yeah, I'll fix this and show it in the booth. Sorry, I think I played with the data set before in the booth, and yeah, I just broke the data set. And yeah, this is the end of my presentation. Please stop by our booth if you have any questions about either this product or data visualization in general. And thanks very much for listening to me.